Hello, I'm Laura Lewis. Welcome to this class on the wave equation. So we're going to look at rearranging the wave equation and substituting in values, understand all electromagnetic radiation travels at the speed of light c and how this is applied in questions, and understand that the wave equation can be used for transverse and longitudinal waves. Okay, so there's a bit of a recap on the wave equation. So V equals F times lambda, often called V equals F lambda. So it's V for velocity. Look at the units here. So it's meters per second. Frequency in hertz or per second. So your base units of that. And wavelength is lambda. So lambda is a Greek letter. So it's in meters generally. Sometimes you give it in centimeter to convert it generally. So this is the wave equation. So it can be used for longitudinal waves, like sound waves. If you remember what longitudinal wave is, it's sort of a series of compressions and rarefactions. Okay, so longitudinal waves, so this would be like sound. So it would be so that's a compression. Okay, often, the most common one is sound you come across. This would be a rarefaction. Okay, rarefaction. Also can be used for transverse waves, so light EM spectrum. So I'll draw one of those in a minute anyway. Water waves also transverse as well. So you get on the ocean, like we saw at the beginning of the slide. Okay, rearranging V equals F lambda. It's only got three parts to it, so it's not too difficult. So often we remember it like this, but we can rearrange it so we can divide both sides by lambda. So there we're dividing both sides by lambda. To get F on its own would be over lambda. With this one, if you wanted lambda on its own, you divide by F. Okay, both sides. So whatever you do to one side, as long as you do to the other, you can do anything. Okay, so again, just a bit of a recap of what these things mean, because people get a bit mixed up on what their meanings are, and the units more than anything with this one. So the waves recapped. So wavelength. So wavelength can be measured from peak to peak. That's a peak and that's a peak. Okay, or one full cycle. So a cycle is that. Okay, you can see there it's one full cycle. Also, another way it can be measured is trough to trough. So depending on what you're given in the exam, you might not be given all these options, but they all measure the same. That's also a wavelength. So they can all be, so peak to peak, trough to trough. So trough is in like what a pig eats out of, that trough, trough to trough, or one full cycle. Okay, that's wavelength. Frequency. So frequency is how many waves pass a point per second. So example, you put a point, you place something somewhere. So example, even could be water waves in the harbour somewhere, and how many waves pass a point per second. So there were 2 meters passing, 2 meters, so that's 2 meter wavelength. Okay, and there was so 2 meters the wavelength. So if there was 1 wavelength passing every second, it'd be 1 hertz. 2 wavelengths passing every 2 seconds, 2 hertz. But you'll see examples, it's actually very straightforward. So here we go, an example. So a water wave with speed 2 meters per second and wavelength of 3 meters passes a harbour. What is the frequency? So V equals 2 meters per second, lambda equals 3 meters. So what I would do is substitute the values we have. So that's V going to put in there, and lambda we're going to put in there. So before rearranging, I'd put the numbers in. You can rearrange first if you're confident in doing that. I'll put numbers in first to see what we have. So we need to find F. So really here we're dividing both sides by 3. Okay, both sides by 3. So we've got 2 divided by 3. Okay, this is F. So it's 2/3. You could even leave it as a fraction. 2/3 hertz or 0.6 reoccurring hertz. You always have a calculator in exams, so don't worry about working that out. So a little bit of a recap. I'm quite proud of this slide. Just showed you the electromagnetic spectrum. Okay, so when I said about light waves, or EM waves, we often call this radio, microwave, infrared, visible. That's visible like when we see ultraviolet, X-ray, and gamma ray. Okay, they're all in the electromagnetic spectrum. So all of these share some properties, like a family of waves. So very important thing to remember, Okay, all electromagnetic waves, EM waves, travel at the same speed in a vacuum. So a vacuum is completely empty space. So it's 3 × 10⁸ meters per second. So also in speed of light. Okay, so obviously the sun's giving out light. So example here, a radio wave has a wavelength of 20 meters. What is its frequency? Okay, because they expect you to know the speed there. So it's V equals F lambda. So 3 × 10⁸ meters per second equals F times 20 meters. So I put numbers in again first. Divide both sides by 20 meters. What's 20? So we get 1.5 × 10⁷ hertz. It seems like a lot, but that's all EM waves are quite a high frequency. You'll see in the next question. So a microwave, okay, like typed it in the microwave oven in your house, has a frequency of 2 × 10⁻14 hertz. What is its wavelength? Again, wrote out the wave equation, always write out every time. So 3 × 10⁸ meters per second, 2 × 10⁻14 hertz is a frequency, times lambda, divide both sides by 2 × 10⁻14 hertz. End up with lambda, so the wavelength equal 1.6 × 10⁻⁻6 meters. Okay, so all the wave equations are kind of the same. Okay, so hopefully that you will copy those out and have a go with that. So thank you for joining the lesson, and goodbye.